Welcome to the flight deck. Now let's talk briefly about the current status of the aircraft. We are currently situated on the ground on the Heathrow cargo apron at stand 607. The aircraft is cold and dark, meaning that it is completely unpowered with no systems running. Given the somewhat chilly outside air temperature today, we will want to be fairly quick about establishing power and air to the aircraft and get things warmed up. At the risk of getting cold, however, I want to run through the full pre-flight procedure. The cockpit preparation is divided between the captain and the first officer. However, in Flight Simulator, we are limited to single pilot operations, so we have combined the two for this first flight, and we will undergo a very comprehensive cockpit preparation, along with some, at times, very detailed explanations. So the first thing we want to do is check the parking brake. One thing to note here is that the aircraft is being loaded and damage may occur to the center gear if the parking brake is set or those wheels are chalked. When the aircraft is being loaded or unloaded, the parking brake should be released and the center gear unchalked. Unfortunately, in Flight Sim, there is no way to chalk the gear, so we will make sure the parking brake is applied now, and it is. Next up, verify the fuel switches on the pedestal are off. Check that the spoiler handle is in the retract detent and disarmed. The flap slat handle should reflect the actual position of the flaps and slats that you observed during the exterior inspection. When the aircraft is loaded from one of the PMDG panel states, the flaps and slats should always be up, so make sure the lever reflects this by being in the up retract position. Verify that the gear handle is down. Check that the fuel dump emergency stop, fuel dump, and manifold drain switches are covered by their red guards. Emergency power selector should be selected off at this time. And we are now ready to breathe some life into the aircraft and get our electrical system up and running. So our first port of call is the battery switch on the overhead panel. The plastic guard must be flipped up before the button can be pressed. Pressing this connects the battery to the battery bus and charger and will give us minimal DC power for essential operations. One good example is the DC electric starter motor mounted on the APU gearbox used for startup. Battery power is used for this particular thing. So one thing to check at this point is the secondary flight display system located between the McDoos. This is a standby EFIS, speed, altitude, and attitude indicator that runs off DC power from the battery. It contains its own gyro, so we'll need time to align. And now we want to establish electrical power to the aircraft, but we do have a problem, however. The ground crews have not yet connected either of the two external power receptacles that we need for full electrical power to the aircraft. The first connects external power to the main aircraft buses, and the second to the galley buses. We need to request that they do so by using the McDo. With the aircraft in its current state, and thanks to careful thinking by PMDG, pressing the menu function key brings up the option to connect external power. So once that is up, we can press line select key 1 right to connect it. On the electrical panel, note the illuminated available light on the external power switch. Pressing this will provide external power to the AC tie bus and will fulfill all of our power needs. External power should enunciate on, and all AC and DC off lights should be extinguished. All 3 generator switches should show arm. This is a feature of the automated electrical system of the MD11, so each engine's integrated drive generator will begin supplying power upon engine start automatically. Also available is galley external power, which will provide power to the galley buses. We won't select this now as we don't have any need for it at this time since we are a freighter. So the sound you're hearing now is the avionics and instrument ventilation system at work, cooling the avionics bay and all of our CRT displays up here on the flight deck, as they can get pretty hot with all of this electricity. Since we have now established electrical power to the aircraft, let's turn on the navigation lights. It is good practice to switch on the nav lights whenever the aircraft is powered to alert others on the ramp that the aircraft is active. Now, while we're on the subject of lights, let's also get some flight deck lighting going. Dome, thunderstorm, overhead, instrument, and pedestal lights are selectable on the overhead. Both flood and backlighting are available for the overhead panel, so the inner rheostat adjusts the intensity of flood lighting while the outer adjusts backlighting. Turning them clockwise increases intensity. Given that it's daytime, we don't need flood lighting. However, I like to fly with the backlighting on. The instrument and pedestal selectors work the same way, so I will select those with backlights on as well. The rheostats can be turned either incrementally with the mouse wheel or fully by double right clicking. I will also turn on backlighting for the glare shield. Next up, let's run through the engine and APU fire test. The button for this is up here on the APU panel. We will push and hold the button to initiate the test, then check a few things. There will be very loud RL warnings during the test, so I will not attempt to speak over them. So just listen up and look at the pointers. Now to simulate holding the button, click on it, hold the mouse button, then move the cursor away and release.
Engine 1, fire. Engine 2, fire. Engine 3, fire. Engine 1, fire. Engine 2, fire. Engine 3, fire.
Alright, all is good there. As much as we love you, Betty, you can become overwhelming and tiresome. So the fire test is particularly important as we want to make sure all of those warning systems are functional, as engine fires must be dealt with without delay. So let's get the APU running now. The APU is a small gas turbine engine installed in an unpressurized area in the rear of the aircraft beneath engine number 2 that provides electrical and pneumatic power to the aircraft. We have two ways of starting the APU. Our first option is the start-stop switch on the APU panel, and secondly, we can use the APU power switch on the electrical panel. We will use this latter method as this will automatically use APU power once it has finally started up. So press the APU power button on the electrical panel now. We get two visual cues on the overhead. First, notice that the APU power button available indication is flashing. Second, note the flashing available indication on the APU power switch. So looking down now at the systems display engine page now, note that the APU data window on the right is starting to spool up. The displays APU N1, exhaust gas temperature, N2, and oil pressure are shown. APU N1 will stabilize at around 63% after it is completely started up. Going back up to the overhead panel now, note that the APU power button on the electrical panel is now indicating on. This indicates that the APU is now supplying electrical power. Had we started the APU with the start-stop switch on the APU panel, we would need to press this button to manually select APU power, much in the same way as we selected external power earlier on. So speaking of which, now that the APU is satisfying our electrical demands, let's turn off external power now. So select the external power button and verify that the on light goes off. Bring up the McDo ground connections page again and press 1 right to disconnect external power. Note that the available lights on the overhead have extinguished on the 2 electrical power switches on the electrical panel. As we checked when we first connected external power, we want to make sure that no AC or DC off lights are displayed. So all is fine now as far as that is concerned. So next on the list is the annunciator lights test. Before you do this, verify that the trim air off light is extinguished. We will in a moment push and hold the annunciator light test here on the overhead. Annunciator lights throughout the cockpit will light up and an RL overspeed warning will sound and repeat for as long as the button is held. So let's do that now and enjoy the light show.
Overspeed. 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 Overspeed.
We will now get the packs up and running and get air flowing through the aircraft. Bleed air is taken from the engines or APU and supplied to the packs, which cool it, then route it onwards and mix it with hot air before distribution. In a moment, we will press the APU switch on the air panel. This switch opens the APU air load valve, and with the air system in auto mode, we'll open the isolation valves and turn on all 3 packs. Taking bleed air from the APU or engines puts them under increased load. Looking at the system's display here, note the APU N1. It currently reads 63%, which we talked about earlier. I will press the APU air switch now. Note how the APU N1 rises, accompanied by the sound of the airflow as the packs turn on. Both isolation valves are indicating open now, and all 3 packs are now running. We now have a fully self-sustained aircraft with both electrical and pneumatic power coming from the APU. Soon we will dive into the McDo and get our flight programmed. However, we need to start the IRS alignment process first. Since this process takes approximately 10 minutes, we want to get started with it. The inertial reference system comprises of 3 inertial reference units that use accelerometers and gyroscopes to continuously calculate aircraft position, track, attitude, heading, vertical speed, and ground speed. It interfaces with both the FMS and the auto flight system and is critical in all phases of flight. The IRS control panel allows control over each IRU. They are currently switched off, and this is indicated by the amber lights. In a moment, we will switch them to nav, which will initiate the align mode. A cargo fire test is performed automatically when the first IRU switch is turned to nav. You will hear an RL alert, and we will verify on the cargo fire panel that the annunciator lights are lit and the appropriate warnings are displayed on the EAD. So no problems there. If the test had not initiated automatically upon selecting one of the IRUs to nav, we would have had to do it manually. Also note that the nav off lights are illuminated. These will extinguish when alignment is complete. We still have another step to perform to allow the IRS alignment to complete. This is done on the McDo, and we will perform the entire FMS setup while we are there. Looking at the McDo, we are still on the ground connections page, so press 6 right to exit this page. then 6 right again to get to the menu. Alternatively, you could have just pressed the menu function key. Bear in mind that the McDo is just a display and data entry unit. The menu page provides the means to access specific subsystems that it can display and that we can control. To access FMC1, press 1 left. Note the Align IRS scratchpad message indicating that further action is required to align the IRS. Clear it by pressing the clear key at the bottom of the McDo. Currently displayed is the aircraft status page. Check that all information here is correct. Model and engine should reflect your aircraft, and make sure your active database is fairly up to date. In the real aircraft, this would need to be valid, but we can make exceptions here in Flight Sim for out-of-date nav data. So press line select key 6 right for the flight plan initialization page. This page can also be reached at this point by pressing the initialization function key. Before we fill out this page, we will set the IRS up for alignment. Note the initialize IRS prompt in 4 right. Our aircraft is equipped with GNS, so our current position is displayed in latitude, longitude form on line 3. Cross-check these values with those displayed on the airport chart for this stand if you'd like, and minor changes may be made with the slew keys on the McDo if needed. Pressing 4 right will transmit the entered position to the IRUs and begin the alignment. 4 right then changes to position reference. This page shows the entered position and the IRS position. The IRS position is understandably blank as the IRUs have not yet aligned. We will now fill out the flight plan initialization page. We have the option to enter either a company route or origin and destination airports. We will explain the company route function on the next flight. So enter Echo Golf Lima Lima / Lima Echo Papa Alpha and drop it in 1 right. The FMC already has a route stored and displays it here. We want to enter our own route, however, so press 6 right to bypass this and return to the previous page. We enter our alternate in 2 right. As covered during the flight planning, this is Ibiza, Lima, Echo, India, Bravo. No route is stored for this, so none is indicated in 1 left. Press 6 right to return. Flight number is AOA 001, so go ahead and select the keys for that. Cruise level will be flight level 330 as we covered before, so enter 330 and drop it in 5 left. Temperature is inputted automatically in 6 left per the standard ISA lapse rate. Headwind component defaults to 0, which in our case is correct as we are not using winds aloft. In 6 right, we will enter our cost index. Now, cost index is a means by which airline management can specify desired fuel economy. A low cost index results in a lower cruise speed and vice versa. Our FS build fuel figures are based on a cost index of 80, so we will use this. Go ahead and type in 80 and you can drop that in 6 right. The flight plan initialization page is now complete. So press the page function key to proceed to the weight initialization page. This is the second page of the 3 initialization pages. We will run down the right hand side of the page first, and then we will do the left hand side. So block fuel is the total amount of usable fuel we will have on board when pushing back from the gate. Usable fuel on board is shown here to the right. This is the amount of fuel on board the aircraft as measured by sensors in the fuel tanks less the ballast fuel. As you can see, we have already been fueled. It is therefore acceptable just to push 1 right to populate the block fuel filled with the current fuel on board. If the aircraft was being fueled currently, we would enter the block fuel on our flight plan. We will now enter our zero fuel weight. This, from the load sheet, is 426,961 pounds. As you can see here, the FMC takes weights rounded to the nearest hundred. With weights, it is generally best to round up, so enter 427 into the zero fuel weight field. Note that this automatically fills out the takeoff gross weight field. We will compare this to our load sheet value once we have filled out the taxi fuel, which we will do soon. We also need to enter the takeoff center of gravity, 23.8, and zero fuel weight center of gravity, 19.7. These are taken from the load sheet once again. All figures on the right hand side are filled out now. Let's move over to the left. Taxi fuel will be 900 pounds, so enter 0.9 or just 0.9. Note that the takeoff gross weight has updated to 486.1 now. This checks out with our Top Cat load sheet. Trip fuel and time are calculated automatically and are not pilot alterable. We will enter route reserve from FS build. This is 7,950 pounds, so we will enter 7.9. We round down for fuel. Since we specified an alternate in the flight plan initialization page, alternate fuel has been calculated and is not pilot alterable. Final fuel includes holding fuel, which is 7.9 taken from FS build, so let's enter that in too. The extra fuel shown in 6 left differs from our FS build calculated final reserve because the FMC has calculated our trip and alternate fuel figures differently to FS build, and that's not a problem. A negative value in this field indicates that the flight may run into reserve or holding fuel, and an insufficient fuel message would then be displayed in the scratch pad. The weight initialization page is now complete, so pressing the page key one final time takes us to the fuel initialization page. We don't need to make any entries or changes here at this time. We are now in position to enter our flight plan, so to get started, press the flight plan function key. The route is pretty bare at the moment, with only Heathrow, a discontinuity, top of climb, top of descent, and Palma de Mallorca in the list. Firstly, we need to enter the Heathrow departure runway and standard instrument departure. If you've watched the procedures section yet, the following will be familiar to you, so pressing the line select key next to any waypoint or airport on the flight plan page takes you to the lateral revision page for that waypoint. To choose a runway or departure, we need to laterally revise from Heathrow. So let's do that now by pressing 1 left to get to the lateral revision page. Press 1 left again for the SID. Available departures are listed on the left side of the screen and available runways on the right. We will select our departure runway first, as that will cut down the list of SIDs. As covered in the planning, we will be using runway 09er right. We can scroll through the list of SIDs by using the slew keys on the McDo. So step through the list until you reach the Midhurst 3 Juliet departure, and then select the Midhurst 3 Juliet departure. So first the runway and then the departure. Verify that the Midhurst 3 Juliet SID and runway 09er right are both indicated and selected, then press 6 left to insert them into the flight plan. We have now been taken back to the flight plan page with runway 09er right as the starting waypoint, so slew through the list until you reach the Midhurst VOR. To continue waypoint entry, we will go to the lateral revision page for Midhurst. So press 2 left for the airways after you go to its lateral revision page, so press 2 left. This page is not too dissimilar to the route page that you might have been familiar with on the Boeing CDUs, so airways are entered on the left and waypoints on the right hand side. Our first airway after Midhurst is the Uniform Lima 151 airway. So let's enter that in now and drop it in 1 left. As far as our route is concerned, this airway ends at Saitet, so enter in Saitet and drop that in 1 right next to the airway. The next airway is Uniform November 859er. And this ends at Barcelona, Bravo, Charlie, November. The final airway is Uniform Whiskey 7. And this ends at Lores. Being able to enter the route information in this fashion is a huge time saver, as all the intermediate waypoints along each airway are automatically put into the flight plan for us. So press 6 left to insert this information and to see what the FMS comes up with. Just as when we entered the SID, we have been returned to the flight plan page, so every single waypoint in our flight plan is now listed here in this page. Let's set the ND to plan mode and step through the waypoints quickly to make sure all is in order. Clearly, I scrolled through those very fast. I have already checked myself that the flight plan is in order, so I need not waste our time now going through it again. It is a very simple task to cross-check waypoints shown in the flight plan page with those on the nav log, so I'll leave you to do that on your own. Do make doubly sure, though, that the altitude and speed restrictions for the departure are correct. In our case, they are, so we are in order. At this point, we are expecting the Lores 1 Papa arrival into ILS runway 24 left approach at Palma. So let's enter that now. Press the line select key beside Lores to get to its lateral revision page. Select 1 right for the star. We will be taking the ILS approach into 24 left, so select this with 5 right. The Lores 1 Papa approach is here in 4 left. Just as we did with the SID, verify that the correct star and approach have the selected indication. All looks good, so let's press 6 left to insert the approach and the star into the flight plan. This approach requires a transition. Our planned transition is the Palencia VOR, so select this in 5 right. The approach is now displayed on the ND along with the missed approach and hold. Again, you should verify that the correct speed and altitude constraints are displayed. Well, there's the flight plan install for you. Not too bad, right? We only have a few things left to do with the FMS now, so press the takeoff approach function key to get to the takeoff page. There are a number of fields here that we will need to fill out. So starting top left, as we covered in the Top Cat brief, we will be conducting a full thrust takeoff today. We will therefore leave this field blank and not enter an assumed temperature. We will be taking off with packs on, so press 2 left to switch this field from off to on. If the packs are selected off here, they will be turned off automatically upon setting thrust for takeoff. For this particular takeoff, we don't want that, so make sure the on indication is shown here as we selected. Enter 20 into 3 left. This is the flap setting for the takeoff that we'll use. Moving up to 2 right now, we need to enter runway slope and wind. Runway slope is not modeled in Flight Simulator, so will be 0. Wind is entered as a headwind or tailwind component in the format H or plus for headwind or T or negative for tailwind. So Top Cat gave us a 14 knot headwind component, so enter 0 for the slope, then a slash H for headwind, 14. Outside air temperature is 5 degrees Celsius. This is entered as 5C. Note the scratch pad message asking us to check the confirm V speeds. The speeds that the FMC has computed are very close to our top cap V speeds. Press the line select key next to each speed to confirm it. 136 knots for V1, 151 knots for VR, and 164 knots for V2. Bear in mind that we climb out at V2 plus 10, so our initial climb out speed will be 174 knots today. Flaps retract, slats retract, and climb speeds are shown here as our transitions to climb thrust, acceleration height, and engine out acceleration heights as well. The FMS setup is now complete, believe it or not, so we're not off the hook yet. We still have several more items to complete on the cockpit preparation procedure. On the cockpit voice recorder panel, where we will go now, push and hold the test button and observe the indicator moves into the green test band and the test tone sounds. Below the cockpit voice recorder panel, verify the generator bus fault lights are extinguished. On the cargo temperature control panel, set the forward and aft cargo temperature selectors. For obvious reasons, these don't matter a whole lot in a simulation. Just make sure that the aft selector is not set to the full cold position, as this may lead to erroneous alerts on the EAD. On the engine ignition panel, verify that the engine ignition off light is illuminated. We will be returning to this panel later before engine start. We will now perform the hydraulic pressure test. It is very important that clearance is obtained from ground crew before conducting this test, as the hydraulic systems will be pressurized. Open the guard and press the test button. The hydraulic pressure test tests the electrical, auxiliary hydraulic pumps, and the reversible motor pumps. The MD11 has 2 auxiliary hydraulic pumps, which are used to pressurize System 3 on the ground or in flight. 2 reversible motor pumps allow transfer of pressure between hydraulic systems 1 and 3 and 2 and 3. This effectively allows the auxiliary hydraulic pumps to pressurize any system so long as the RMPs are operational. The purpose of this test is to check that all of these systems are working correctly, as hydraulic redundancy is very critical for safety. First, the test switches on auxiliary pump number 1. Note the on indication on the switch and the indication on the SD. Follow the green lines to see what happens, and hydraulic system 3 pressurizes. Next, it switches on auxiliary pump 2 and opens up the systems 1 and 3 RMP. This pressurizes system number 1. Next, it opens up systems 2 and 3 RMP, which pressurizes system 2. It then closes the RMPs in turn and then turns off both auxiliary pumps. The test is complete once hydraulic pressure test button test indication extinguishes and the system depressurizes. To be able to do this test, the hydraulic system must be in auto mode. We have another test coming up, albeit much simpler than the last. On the electrical panel, verify that the smoke electric air selector is in the normal position. Drive 1, 2, and 3 and cab bus switches should also be guarded. So here comes the test. Move the emergency power selector from the off to the arm position. The emergency power off light will extinguish and the on light will illuminate. The emergency power system undergoes a self-test that takes approximately 30 seconds. Upon its completion, the light will go out. So leave the emergency power selector in the arm position. In this position, it is armed for any situation that might require it, say an electrical failure. So check the error panel and make sure it is configured correctly. All looks fine for our current situation here. The mask switch should be guarded, and it is. Give the fuel panel a quick check for abnormalities. Nothing is wrong here. Have a guess why pumps 1 and 3 are indicating off, but pump 2 seems to be on. The APU takes its fuel from tank 2, so the corresponding pump runs automatically when the APU is switched on. You can see this clearly when we look at the fuel quantities. Tanks 1 and 3 show 20,000 pounds, while the APU has clearly been eating away at tank number 2, just a couple of 100 pounds there. So moving down to the lights panel, move the emergency lights switch to the arm position, push and hold the test switch, and observe emergency lights test pass on the EAD. Release the switch and the alert should no longer be displayed. No smoking and seatbelt signs should be on at this point, although they don't matter too much since we're on a freighter with minimal crew facilities behind the flight deck. Exterior lights, landing lights are retracted. Nose gear light is off. Left and right wing and runway turnoff lights are off. Nav lights are on as we did before. Logo lights are set to off. Beacon and high intensity strobe lights are off as well. Moving up to the evacuation control panel now, set the evacuation signal switch to arm. Over on the ground proximity warning system panel, we will test the GPWS, RL, and visual alerts. So hold the switch in the test position and note the glide slope warning lights and the indications on
Glide
the PFD.
Slope. Pull up. Terrain, terrain. Pull up. Sink rate, sink rate. Pull up. Terrain, terrain. Pull up. Don't sink, don't sink. Too low, terrain. Too low, gear. Too low, flaps. Too low, terrain. Glide slope.
Flip the switch back to normal to finish. On the automatic flight system control panel, flap limit and elevator fill selector should be in auto, and all lights should be extinguished. On the cabin pressurization panel, verify that the cabin pressure rate selector is in the auto position and the outflow valve is open and the ditching switch is guarded. On the anti-ice and windshield control panel, all lights should be extinguished. We will now set up the glare shield. Since we are flying in Europe, we are using hectopascals as our pressure unit. Set hectopascals and confirm the change on the PFD. We also want to set QNH at this point. So QNH is 990. Use the black outer knob to change this and watch the indication on the PFD. Confirm that the indicated airspeed Mach window reads 250 knots and that the heading and track window displays the actual aircraft heading. You can cross-check this with the standby compass, ND, and PFD, and it looks like everything matches up here. Bank angle selector should be in auto, and the auto flight system override off switch should be up. Altitude display window reads 10,000 feet. On the source input selector panel, ensure that the EIS source selector is on 2 and that all lights are extinguished. The captain's side should be on 1. Static air selectors should be on normal. All display units are powered and functioning correctly. Clock on the ND is confirmed correct. We will now test the gear warning system and the SD configuration synoptic. With the gear down and locked as it is now, 4 green lights should be illuminated and the center gear normal up light extinguished. Select the configuration synoptic on the SD and verify that 4 greens are enunciated there also, and they are. Pull the gear lever out of the down detent but not up, and all lights should indicate red when you do this. Release the gear handle and observe the indications return to green. And there we go. On the secondary flight display system, switch the units to hectopascals and set QNH 990. Verify that speed, altitude, heading, and attitude are displaying correctly, Heading was not displayed last time we looked at this instrument as it runs off IRU number 1, which was not aligned at the time. Next to be tested is the takeoff warning system, so verify that the overboost stop is positioned correctly, and it is. Move thrust lever number 1 full forward and listen out for the warning horn and RO alert.
Brakes.
Observe the warning is silenced once the thrust lever is brought back to idle. Repeat using thrust levers 2 and 3 together.
Brakes.
Get to the Systems Display Status page, and we will review all the items here. Everything listed here is to be expected at this stage. Auto brakes have not yet been set, and door number 1 is still open. Digital flight data recorder is not operating, as when the aircraft is on the ground, it requires the engines to be running and the parking brake to be released. Verify that rudder and aileron trim are set to 0, and they are. Now let's check that the air-driven generator release handle is full down and safetied. If the ADG is deployed, it cannot be reset in the air and must be done on the ground by the ground crew. So it's important to check. We will now check the indicated fuel quantity, set the SD to the fuel synoptic, verify that the individual quantities in each tank add up to the total quantity. They do. We loaded 60,000 pounds of fuel, and that is what is indicated, minus that which was used with the APU so far. So that's plenty good there. Rotate the flap takeoff selector thumb wheel until we get to 20 degrees. When we move the flap handle to the dial a flap detent later on, 20 degrees will be set because of this setting we just did. Airspeed on the FCP should be set to 250 knots or climb speed, whichever is higher. In our case, they are equal, so the current setting is correct. Now verify the taxi is indicated on the PFD speed tape. This indicates that the IRS alignment has completed. Set the auto brake selector to the takeoff position. We will now breeze through the cockpit preparation checklist. Given our comprehensive preparation, this should be purely a checklist with no do items. So first let's go to the SD status page. Checked. Hydraulic panel auto. Fuel panel auto. External lights set and checked. Evacuation command armed. Fuel switches off. Rudder and aileron trim 0. The next item on the list is to check the FMS. I normally start on the initialization pages and cycle through them, checking everything. I then go to the flight plan page and quickly step through the route, verifying that everything is in place again. And there we go. I then go to the takeoff page and scan it quickly. I then go to the navigation radio page. This is actually something we should have checked earlier. We need to have the London VOR tuned for the departure. It has been auto-tuned by both VOR1 and VOR2. However, I will hard tune it myself and make sure it doesn't get retuned. I will also enter the Midhurst VOR into VOR number 2, which is 114.0. We will clear these later so that they can auto-tune again. Flap takeoff selector is set to 20 degrees. FCP checked. Actually, wait a minute, we missed something here. Heading needs to be set for takeoff, so runway heading is 092 degrees. And altitude also needs to be set for our first cleared altitude, which is 6,000 feet on the SID, so I will set that as well. That's the beauty of checklists for you. We actually caught something. Taxi is indicated on the PFD. Auto brakes are set for takeoff. Cockpit preparation checklist complete. To avoid further repetition, we will now run through the before start and pushback checklists while actioning the items on the list. Doors and windows, the forward left cabin door is open. Thankfully, PNDG again has provided a doors page in the McDo where it is possible to open and close and arm and disarm doors. So press the menu function key, then 6 left for shortcuts. The forward left door is a cabin door, so select 2 left. Press 1 left to close the door. You will need to wait a few seconds for it to close completely. Then press 5 left to arm all cabin doors. This will extinguish the door alert on the SD, and we will verify this now. And there it is, it's gone. On the hydraulic panel, turn on auxiliary pump number 1. As you should well know by now, this provides hydraulic pressure for system number 3, which should ensure brake pressure for the parking brake, and will allow us to move the horizontal stabilizer. Check again that the parking brake is set. We will release it upon clearance from the ground crew. Set the beacon light on. This acts as a warning to anyone around the aircraft that we are about to move and or start the engines. Turn engine ignition A or alpha on. The engine ignition off light should go out and all 3 packs will be turned off automatically. Again, this is another feature of the MD11's amazing automatic systems. The packs must be turned off prior to engine start to allow the APU to provide sufficient bleed air to the engines to get them turning. Fuel panel is set to auto, and before start checklist is complete. Finally, after 45 minutes of preparation, we are ready for pushback and engine start. We will commence pushback, then start our engines as we push back. PNDG offer a pushback tool in the FS Action system accessible to the McDo, so press 6 right to return to the FS Shortcuts menu, and pushback is at 1 left. Here we have the option to select different settings for our pushback. The straight length we require for this particular situation is 108 meters, so let's punch that in. We want our nose pointing 90 degrees to the right of our current orientation, and units in meters, and we do want voice. We are cleared to push back and everything is set here, so press 6 left to commence the pushback sequence.
Go ahead, Captain. We're all set to go up here. We've been cleared to push and start at your discretion. Roger that, ready for push. Power and air are clear, doors closed. We are ready for pushback. Release parking brake, please.
Release the parking brake when asked to by the ground crew.
Okay, parking brake is off, cleared to push. Brakes off, here we go.
Now that the brake has been released, we will start to move back. We can now proceed with engine start. Our normal start sequence for the MD11 is a 3-1-2 order. So first we need to switch the SD to the secondary engine page. Now pull the number 3 start switch. The switch will illuminate amber, indicating that the start valve is open. Check for oil pressure rise on the system's display. Watch N2 rotation increase as APU bleed air spins the turbine. At 15% N2, move the fuel switch on. Note exhaust gas temperature rising, and this must not exceed limits. At about 45% N2, the engine start switch will pop in and the light will extinguish. This indicates that the starter valve has closed. Once the engine stabilizes, engine start is complete. We will repeat the process for engines 1 and 2, so pull the number 1 start switch now. Again, it will illuminate amber. Oil pressure rise. N2 increasing to 15% at 15%. Which is about right. Now fuel on. Observe the EGT rise. All readings are remaining within limits. The hydraulic, electrical, pneumatic, and fuel systems will configure themselves automatically as each engine starts. That click was engine number 1 start switch popping back in. We will repeat the process one last time for engine number 2.
Push is complete. Set parking brake, please.
Alright, brakes are set and pressure
And
control.
set the brakes when you need to.
Okay, sir. Tow bar is on. Pin is out. Watch.
Pull the start switch and observe illumination. As always,
Alright, guys,
oil
thanks.
pressure
You're cleared
is
to disconnect.
rising.
We will be watching
N2
for the pin and,
increase.
release from guidance on the right side of the airplane, and we'll see you guys next time through.
Roger that. Have a good flight.
15% fuel on. Observing an EGT rise. All readings within limits. You should always monitor EGT until the engine has stabilized. Should EGT rise above the limits, switch off the fuel immediately to limit damage to the engine. And as you probably heard there as they were interrupting us, the pushback is complete and we have set the parking brake. One thing we failed to mention while we were starting up the aircraft is the cargo door test. This happens when starting engine number 3 and is presented as a level 0 alert on the EAD. So we can test it now, looking right above where the air is flashing there. And that completes the test. We just didn't want to interrupt the startup sequence. With all 3 engines running, we are good to go on the after start procedure and checklist. Again, we'll combine these into one process. So anti-ice, given the icing conditions, this will be switched on. Don't forget the Topcat worked this into our takeoff performance computations earlier. On the air panel, push the APU switch to off and observe that the on light extinguishes. This closes the APU bleed valve, and after a cooling period of about a minute, the APU will shut down automatically. Engine number 2 will now supply bleed air to pack number 2. Hydraulic panel, all lights are out and it is in auto. Ground equipment is clear of the aircraft, and the after start checklist is complete. Because there's only one of us on the flight deck, I will complete the taxi checklist before we get moving. So flaps set to the dial flap detent, which should give us 20 degrees per the flap takeoff select wheel. Arm the spoilers. Select the configuration page synoptic on the systems display. We will now check the flight controls. Rotate the control wheel full left. Observe the green aileron and spoiler boxes, which appear when the control surfaces are at the full deflection. Rotate the control wheel now full right. Observe the green boxes again. Now let's neutralize the controls. Move the control column forward. Now full aft. Return the column control to the neutral position. Now deflect the rudder full left. Now full right. And back to neutral. Return the systems display to the engine page. We will now set the stabilizer trim for takeoff. So go to the takeoff page on the McDo and note the trim value, which we see here as 6.5. We will set this now. On the SD, note the stabilizer trim position indicator. Adjust the trim now to indicate 6.5. This should be within the green band limit. So there we go, 6.5. To finish up the checklist, let's check the takeoff data page again and ensure that all information is correct. Flex filled is blank, packs on, flaps 20. Slope, wind, outside air temperature are all correct. V speeds have been filled out and are very close to what Topcat calculated for us. Everything looks fine to me, so that means the taxi checklist is complete.